Okay, we're going to skip 4. I promise I will do this one with you, so you'll still get this one. But let's go to 5. 5 is where we're going to start for this video. This is your Unit 6 test review. It's over probability. We've gone through 1, 2, 3. I'll go over 4, and so we're going to start at 5. Alright, it said Alex has a bag of Jolly Ranchers. 14 are green flavored, 18 are cherry flavored, and 13 are grape flavored. 11 are watermelon flavored. 9 were blue raspberry flavored. So he puts his hand and takes one without looking. What is the probability, written as a percent, that it will not be grape flavored? Okay, first of all, I hate when they write numbers out in word form. So mark this out and write 14 above it. Mark this one out and put the number that it is, 18. 13 is already there, 11 is already there, 9 is already there. So we have to always find the total. So that is the reason I wanted to do this, because you might have skipped over them if you hadn't seen the numbers. So we would have to add up all that there was. So that's 14 plus 18 plus 13 plus 11 plus 9, and you get 65. So 65, and now we're looking for ones that are not grape flavor. So everything but grape flavor. So we're just not doing this. So everything else you can use. So it would be, you would have to add them up. 14 plus 18 plus 11 plus 9. Okay, and you get 52. Alright, so this is the probability. Woohoo! But it's asking it as a percent. So we know that it is part over whole, percent over 100. Or we could have just divided and then multiplied by 100. It all works out the same. So I'm going to actually do that in my calculator. I'm going to do 52 divided by 65 times 100 is 80. So this would be 80%. If I was going to solve a proportion way, it would be 52 times 100. You can barely see it. Sorry, guys. 52 divided by 65, and you still get 80, and it's a percent. So 80% is your answer. Okay. Let's move on to number 6. It says Kyle has a bag of numbers 1 through 20. If he randomly chooses 2 tiles without replacing, ooh, that's important, that without replacing, that means our denominator, our sample size will change. What's the probability that Kyle will pick 2 tiles that are prime? So first I'm going to write all my options out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Alright, so you have to click off all the things that are prime, or not prime. So I know 1 is not prime or anything. But 2 is prime, 3 is prime, 4, 2 goes into, 5 is prime, 7 is prime, 8, 4 goes into, 6, 3 goes into, 9, 3 goes into, 10, 5 goes into, 12, 6 goes into, 13 is prime, 14, 7 goes into, 15, 5 goes into, 16, 8 goes into, 17's prime, and 19's prime. So those are all my prime numbers 1 through 20. So remember, I'm drawing 2 tiles, so I have 2 options. I have one option and then I have the second option, okay? So my first option would be, out of my 20 tiles, I have 1, 2, 3, 4, 5, 6, 7. Okay? Then, my second time, we're going to pretend I drew one. So, we're now down to 19 tiles because I drew one. And I drew a prime number, so I would have to count how many are left. 1, 2, 3, 4, 5, 6. So then I'm going to multiply straight across. 7 times 7 times 6 is 42. And 20 times 19 is 380. Those are huge numbers, but I'll notice that they both have even numbers at the bottom, so I know I can divide by 2. So 42 divided by 2 is 21, and 380 divided by 2 is 190. So my answer is 21 over 190. Good job. Okay, 2 fair-sided dice. So if I have 2, I'm probably doing complex probability again. Both are numbered 1 through 6, are rolled 50 times. Ooh, when I see this 50 times, it usually means proportion. So this usually means proportion. Right? And solve an equation to explain how many times 5 and an even number are likely to be rolled. So here's my number die. These are the options for my number die. So for the first roll, I want to get a 5. So that would be 1 out of 6. But then, because I'm doing it twice, I have to have an even number. So even numbers are 2, 4, and 6. So 3 out of 6. So then I'm going to multiply straight across. 3 times 1 times 3 is 3. 6 times 6 is 36. So this is my probability, but I want it out of 50 times. So I have to set a proportion because it said probability. So here is my proportion as it asked, where it says write an equation. This is my equation. Then I'm going to multiply. 3 times 50 divided by 36. And your answer is about 4 times. So that's your answer. So it's about 4. But this, I will tell you on the test, they don't want you to solve it. They just want the proportion. Okay? Alright, now it says, Marilee spun a spinner several times and recorded the data below. It shows this is the frequency, so this is our table. And so we have to find out how many times she spun the spinner. So we have to add all these numbers up. So we have to go 10 plus 8 plus 15 plus 19 plus 26 plus 11 plus 16 plus 15. Alright, so we get 120. That's how many times she spun the spinner. And yes, that's a tongue twister. So, the experimental, ignore this part for right now. The experimental is going to be how many times she got it over her total. Now, that can reduce to become 1/12. Remember that 0 trick. But I'm going to leave them in non-reduced form just so you can see it at first. This would be 8 over 120. This is 15 over 120. This is 19 over 120. This is 26 over 120. This is 11 over 120. 16 over 120. And 15 over 120. Now, yes, I am going to want you to reduce these, but as long as you get this part, I'm pretty good. But I will tell you, this can reduce by 4. So 8 divided by 4 is 2. 120 divided by 4 is 30, and actually it could reduce by 8. Oops, it can reduce by 8, so it could become 1/15. Okay, this was 1/12. This one can reduce by 15, and it becomes 1/8. And I see I have two of them. This could reduce by 8, and it becomes 2/15. This is as low as it can go. This can reduce by 2, so it becomes 13/60. And this is as low as it can go. Okay? So yeah, some of them reduce, some don't. Again, if you can get the number over the total, I'm good. The reducing fraction doesn't bother me as much. Now let's go to theoretical. We have to assume, and this is the hard part about this, is we have to assume that they're all equal spaces, that they were equal sized. So again, theoretical is there's one red thing out of 1, 2, 3, 4, 5, 6, 7, 8. So in theory, all of these have a 1/8 chance. And the big assumption of this is that they're all the same size. Okay? So, again, remember, theoretical is a lot easier than experimental. Now let's go to number 9. Kennedy randomly selected a group of 30 students from her school and asked them where their dream vacation destination would be. She records her responses in the table below. There are 740 students in her school. How many students would choose Cairo? Okay, so Cairo, Egypt is really all I'm caring about. So I'm primarily caring about Cairo, Egypt in this 9. Now, we know this is going to be a total. So this is a proportion. And you should get strong enough with proportions that you can just start recognizing them. Now, it is still a probability problem, so we have to know how many people she asked. It tells me a group of 30, but let's just make sure. So we're going to do 3 plus 9 plus 6 plus 8 plus 4. Indeed, it's 30. So 9 out of 30 people like Cairo. And we're wanting the huge sample size of 740. So there's our proportion. So we're going to multiply 9 times 740 divided by 30. And you get 222 students. Okay? Okay. Now, Chelsea plans to spin a spinner 55 times. This should be a proportion. You should start noticing that. Write and solve an equation to predict how many times it will land on 3. So how many 3s do you see? I see 1 3 out of how many here? 1, 2, 3, 4, 5, 6, 7, 8. So out of 8, I see 1 3, but it's out of time, so I know it's going to be a proportion. And I'm going to cross multiply, divide. 1 times 55 divided by 8 equals about, and that's the interesting one on this, it's going to be about 7 times. So you're going to want to round up. So you're going to say about 7 times. About 7 times. You could have said 6.7, or excuse me, 875. That's the correct answer, but that's not a very logical. We're going to round up. Okay? Now, draw a tree diagram representing all the possible outcomes of flipping a coin and rolling a number cube. We've actually done this exact experiment before. So flipping a coin, you can have heads or tails. So to draw a tree diagram, you just write your 2 options, and then it must branch off all the next possibilities. So rolling a number cube. So we could have a 1, a 2, a 3, a 4, a 5, and a 6. All if we had heads. But what if we had tails? We could have a 1, a 2, a 3, a 4, a 5, and a 6. So count up how many you have. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 possible outcomes. But most importantly, it wants the tree diagram. So it wants this more than that. But there you go. Alright, number 12. Nora spins a spinner 75 times. The table shows, alright, it's that 75 times again. Proportion. Don't let the proportion throw you off, okay? So, spins a spinner 75 times. So, we have to figure out what is our total sample space. 18 plus 11 plus 25 plus 21. So, 75. It was what we wanted. Now, 300 times proportion. Okay? So, 75 is my number, and it wants to know it for each different one. So, we have actually 4 proportions to solve this problem. Okay? 1 for A, 1 for B, 1 for C, and 1 for D. So, the first one would be 18 out of 75 equals, and we have 300. There's the first proportion. And let's just solve it. I'm not going to even go there. I'm not going to go rush. So 18 times 300 divided by 75 is 72. So this will be 72 times. Okay, 72 times. Okay, let's try it for B. It's going to be 11 out of 75. But we want to know how much it is out of 300. So there's our proportion. So 11 times 300 divide by 75. And you get 44 times. Which makes sense. It's a small 11 is a smaller number than 18. Okay, next one, 25 out of 75 equals 300. Okay, again, 25 times 300, not 3,000, 300, divided by 75 equals 100 times. So this would be 100. And again, that makes sense because 25 is slightly larger than 18. And 18 was 75 or 72 times. This is 100 times. If you make the prediction that 21 is going to be somewhere between 100 and 72 times. Let's see if we're right. Okay, so we have 21 out of 75. We want to know for 300. So 21 times 300 divided by 75, and you get 84. Were we right? Is 84 between 72 and 100? Yep. So all of our answers are logical. And yes, this one requires a lot of work. They're simple work, it's just proportions, but it does require quite a bit. Okay, number 13. Alice Star has a bag of marbles. They contain 21 red, 7 white, 14 black. Write a ratio representing the complement, which means everything that is not a black marble. So essentially what they're asking is for not this black marble. So we first have to figure out what is, how many are in the bag. We have to add them all up. So we have to do 21 plus 7 plus 14. That's going to be my total. Now I want everything that's not black. So then I have to add 21 plus 7, and it equals, you can barely see it, 28. So there's my ratio. However, they're going to make us reduce it. This is a correct answer. Guys, normally I would accept this. However, they're going to want it simplified. So let's try simplifying it by 2 because they both have even numbers. So 28 divided by 2 is 14. 42 divided by 2 is 21. I'll tell you it can reduce again. And if you get out your journal, you can see it now. Now it will be pretty obvious what it could reduce by. So look through right here, 14 and 21. It reduces to 2/3 when you divide by 7. So if I divide, this was to get it down by 2, this one is to get it down by 7, and it becomes 2/3. Okay? Alright, we'll do 14. Wren rolls 2 fair 6-sided number cubes numbered 1 through 6 and records their combination. Even and prime. Alright. When we're rolling a 6-sided number cube, we're number 1, 3, 4, 5, and 6. Alright, so your even numbers are going to be 2, 4, and 6. So it's going to be 4, where there's 3 out of them. Your prime is going to be 2, 3, and 5, so there's 3 of those. So record their combinations. So 3, but some of them overlapped. Okay, so you're looking for even and prime. So the only one that is even and prime is 2. So this would be 1/6. Okay, odd and a multiple of 2. Well, that's 0 out of 6 because no multiple of 2 is odd. And then has a sum that is prime. This one is a complex probability that we're going to skip. This is the whole reason I actually wanted to skip this question to begin with. Because the sum of prime, there's a lot of combinations and we're just going to skip it. Okay? The question on the test that is like this does not have that complicated of answer. Alright. Ivy brought a package of highlighters containing 1 yellow, 1 orange, which I thought I had, 1 orange, and 1 pink. Okay? Oh, here, I have an orange. So that is what she has. She has a yellow, an orange, and a pink highlighter. She wants to pull out 2 markers out of the package. What are her combinations? Okay, again, we did this, you guys. We did this with the cards. So her combination of pulling out all the ones, she could pull out, remember, she could pull out a yellow and orange, or a yellow and pink, or she could do, if yellow is out, a pink and an orange. Okay, So how many combinations? How many outcomes does she have? She has 3 possible outcomes.
Pardon the interruption. Jacoby Parnell, come to the office, please. Jacoby Parnell, come to the office.
Okay, this next one. If the package contains a blue highlighter, so we got a blue one in the mix, and a green highlighter, so we got a green one in the mix. Create the list for showing all the possible outcomes she could use. Still, she's only going to draw 2 out. Okay? So, she could have, I'm going to start with orange. She could have the orange and the pink one. She could have the orange and the yellow one. She could have the orange and green one. She could have the orange and blue one. Okay? Those are all her possibilities with orange. But then she could have a yellow and blue. And then she could have a yellow and green. And then she could have a yellow and pink. Now, if she grabs yellow and orange again, we already have that combination right here. So I don't have to write YO because I already have it right there, okay? So, essentially what it's saying is the yellow is out and the orange is out. We've used all those combinations. So now let's go with pink. We'll do pink. We could do pink and blue. We could do pink and green. But even if I grab pink and yellow, I already have that one right here, so I don't need it again. Okay? So now pretty much all my pink ones are out. The only last combination could be blue and green. And I don't need to do green and blue because it's the same thing. So, how many combinations do I have now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 outcomes. Alright, how did the number of possible outcomes change when it contained 5 markers instead of 3? Well, it more than doubled if you really look at it. 3 and 10, there's a lot more combinations. So it tripled. So it was more than 3 times the number of outcomes. Okay? So more than 3 times the number of outcomes, because 3 times 3 is 9, which is still not 10. So 3 times as many outcomes. Alright, again, this is your review. I'm sorry this is a 30-minute video, but we will go back and do number 4 in class. Have this done. If you get your parents to sign it, you'll get extra points. And your test is tomorrow. Bye, guys.